you know how to do this, I think, already. So we're going to touch on this real quickly. How many of you guys felt like adding, subtracting, multiplying, dividing functions? Probably the easiest section we had so far in chapter 4. What if I told you that today is kind of a spin-off of that? It's pretty easy compared to some things we looked at earlier in the chapter. Would that make you feel happy?
Sure.
Good news is we're at the end of chapter 4 today, so this will be the last section we have to cover. And won't take too long to get through this today. So here we go. Guys, 4.6 is titled Inverse Functions, or Inverse of a Function. I'm going to volunteer to read my essential question today that we're going to try to find an answer for.
How can you sketch a graph, the graph of an inverse of a function?
How do you sketch the graph of the inverse of a function? Okay, so we're going to be looking at inverses and what they mean, all right? In order to be able to sketch a graph of the inverse of a function, goal-wise, we need to first of all explore inverses of functions, what they mean. We're going to find and verify inverses of nonlinear functions. I'll show you how to do that. Look at a few real-life problems involving inverse functions today, okay? So,
Yeah. There you go. Up. Yeah. Over.
better?
Yeah.
Oh, kind of missed right in here, didn't I? I don't know. This kind of drives me nuts. I think I'm getting a new board over break, though. And I'm trying to, you know what I'm trying to do? I'm trying to get the Vimeo one that I don't need any of this stuff anymore. I can just do it with my finger. There's a board that you can just do this stuff, touch the board, and somehow it reads. It's pretty cool. Well, everything's going to be the same. My finger will just triangulate with this here. I won't have this thing anymore. I'll just be pushing stuff, and it's going to be pretty cool. If I get it, okay? All right, guys, vocab here real quickly. Inverse functions, kids. Inverse functions are going to be functions that do what? Undo each other. They are called inverse functions. Now, definition-wise, here's what we're going to need to know definition-wise. Functions are inverses of each other if the following is true. And we'll talk about this rule in a little bit. But we're going to talk about this. If f of g of x, that's a parenthesis up there. If f of g of x is equal to x and g of f of x is equal to x, all right? This is some notation stuff that we're going to talk about in terms of how do you verify if two functions are inverses of each other, right? But right now, inverses are functions that undo each other. And I think to keep things kind of simple right now, if I ask you what's the inverse of addition, you'd tell me what? Or if I said the inverse of multiplication, you would say, or if I would say the inverse of multiplying by a fraction, you would say multiply by the reciprocal. Exactly. So what I want you to keep in mind today is this. Inverses are going to be kind of like undoing operations, okay? And you've done that a million times before. But notation-wise, this is what we're going to have to show if functions are inverses of each other, okay? All right, next term. Is it input, kids?
Yeah.
Input is simply the what? X value. Output's simply going to be the y value for f of x. So basically, x is your input, y is your output. Understand this. If you ever see something like f of x like this, that's the same as saying that's like a y value right there. Okay? So x is your input, f of x is going to be an output, or you would say y is an output. Okay? Inverse operations. What does this say, kids? Opposite operations. So I would say the inverse of addition is what? Inverse of addition is subtraction. So you know inverse operations. Okay? We're going to talk about what a reflection is. I think you guys know what a reflection is. It's a flip over a line of reflection. And then a line of reflection is simply a line of symmetry between two lines or figures. Okay? So, I don't know. Here's a line of symmetry. If I drew a figure like this, this line of symmetry is right in the middle of it. So if I would draw a line from, say, maybe this point to your line of symmetry and this point to your line of symmetry, what would be true about those two distances to the line of reflection? They would be equal. So a line of reflection is going to be right in the middle of two figures, or 2 points, if you will. Okay? All right, so let's get started on this. Example 1. I think vocab-wise you should be okay. You should be okay. So here's how this works. Writing a formula for the input of a function. First of all, it says let f of x equal what, kids? 3x minus 5. It says solve y equals what? Okay, anytime you see f of x, that typically can be replaced with what variable, kids? Okay, is y an input or an output? Okay, when they say solve for f of x, they're basically saying solve for, when they say solve y equals f of x for what here, kids? They're really saying get x to be alone, okay? So if I replace the f of x with y and just put it in xy form, what would you have to do to both sides of the equation to accomplish getting x alone? Where would you start, kids? Add 5. Okay, so this would become y plus 5 equals what, kids? Now what are you going to do? Divide everything by 3. So if I wanted to get x all alone, y was equal to 3x minus 5. That means that x is equal to y plus 5 over what, kids? So if I say solve f of x for x, that just simply means get what alone, kids? Just means get x alone, okay? Now, it says right here, find the what? Input when the output is what? Okay, sometimes I get confused on this input-output stuff, so what I like to do is say, okay, input, is that an x value or a y value?
X.
And then the output is a, okay? So basically they're really saying find x when, but what I really did down here, kids, I just wrote an equation for x, didn't I? So what could I plug in for y to solve for x right here? Yep, just take that. X would equal my y value, which is negative 11, plus what first, kids? And this is all over what? Okay, help me with the math here. What is negative 11 plus 5? Negative 6 divide 3. What have we got, kids? Okay. That in itself should be pretty straightforward for you. Okay? Anything there that's earth-shattering or you don't understand? That's probably one of the easiest things we've looked at all year, I'll bet. Right? Okay. Questions first page. Anybody? Questions first page. All right, let's see what we can get ourselves into here. Let's go to the second page here and see what we have. Okay, so example 2 says finding the what? Inverse of a. Okay, I'm going to put rules up here. I left a little room up top here. Rules to find inverses. Now, you may have talked about this a little bit in other classes because you had to do it for some problems. Anybody know how to find inverses or what the rules are? Anybody remember or recall or have experience with it in a prior class? You're kind of close. Maybe this will ring a bell. I'm guessing some of you have had some exposure to this. So step 1 right here. To find an inverse of any function right here, if it exists, you have to switch your x and your y value. Switch x and y. Okay? Always going to switch x and y. Okay? Then, once you've done that, you ready to figure this out? You're going to solve for y. Okay? And once you've solved for y, you'll have your inverse. And we'll make sure that we get this back into the right notation that we're expected to have, but I'll show you how this works. Okay? First of all, it says find the inverse of what, kids? Two x plus 8. Okay, no problem. Okay? Guys agree that this is really the same as saying y equals 2x plus 8 initially? You guys agree with that? Okay. Well, if I want to find the inverse of that function, or the opposite of that function, if you will, what do I have to do first? Flip my x and y. So we're going to call this x equals what? All right. Now we have to get what alone, kids? y alone. Okay, no problem. Here we go. What would you do first then? So I would have x minus 8 equals, would you all agree, 2y? Okay, now what are you going to do with everything else? Okay, and we get y equals x minus 8 all over what? Okay, here's the situation I want to make sure you're aware of. First of all, is y alone. Okay, listen to what I say in this function right here. In the original function, y was equal to 2 times what? When I take 2 times x and I say, ooh, there was some multiplication involved with that variable. What's the inverse of multiplication? Well, when I multiply by 2 in my inverse, is there any division of 2 in here anywhere? Oh, yeah. Okay. We also added how much? In the original function, we're adding how much? 8. What's the inverse of adding 8? Does minus 8 show up anywhere in your inverse function over here? You bet. Now, kids, here's the situation. They're probably going to simplify this a little bit if they can. Really, how many x do you have up here? Okay, they're going to probably call this 1/2 x. And then how about the 8 divided by 2? Okay. Now, notationally, here's what you're going to see. Originally, this function started out not as y equals 2x plus 8, but it started out as f of x equals 2x plus 8. To indicate that this is an inverse, this is the notation they're going to write in the end. Instead of putting y down here, they're going to write it as f to the negative 1 power. That just simply stands for inverse. F inverse of x is equal to 1/2 x minus 4. This f to the negative 1 just simply means, hey, this is the inverse of that function, right? So your rules, switch what and what first? X and y. Solve for what? If possible, when you get y alone down here, go ahead and do what to your answer? Simplify it, maybe rewrite it, and then when you put it in notation form for an inverse, you're going to write f inverse of x is 1/2 x minus 4. Okay? I want to show you something here about these two functions. Okay? Before I show you this, do you have any questions about how I got that inverse first? Yes?
How'd you use the 1/2?
Where did the 1/2 come from, kids? So this is really 1x over 2 right here, right, Braden? So 1/2 x is where that came from, kiddo. See it? Okay, I want to show you something, kids. I'm going to run to Desmos. This is what it means graphically for inverses. Oh, Desmos, where are you hiding at today? All right. Kids, I need someone to tell me what the original function was. 2x plus 8. All right. What was the inverse function? 1/2 x minus 4. Okay, let me put this in projector mode so we can see this better. Okay, here's the situation I want to show you. Okay, right here are two graphs, the original function and the inverse function. Okay, what this is going to talk about, kids, is the following. Basically, we're talking about if I have an input and an output, the inverse would then go output input. We're basically replacing y and what when we start this problem. When we start to find inverses, we're replacing y with what? And vice versa, right? Watch what happens here. This happens every time you have a function. Okay? If I type in here y equals x, watch where this line goes, this third line. Watch where it gets put in at. Where did it get put in at? Right in the middle. This line y equals x is a line of reflection for any inverse function. Meaning if I would take this blue line and flip it over the green line, this is what would happen, the red line. Okay? Guys, check this point out right here. What is this point? Negative 4 comma 0. What's the inverse of negative 4 comma 0? 0 comma negative 4. Oh my gosh. All the y and x did was what? Switch around. Right here is another point. What's this point up here? 0 comma 8, meaning the inverse. Which point should be on the inverse? 8 comma 0. Is it? Okay. The inverse of a function basically takes my input and output and does what with it? Flips them around. That's all it's doing. Okay. And then what I would also tell you and hammer home is this. Inverses are going to be reflective around the line of reflection. And my line of reflection will always be what? Y equals what? X. So what I think I want you to do here is go back to your first page of notes. Go down to this line of reflection. And when we talk about inverse functions, your line of reflection is going to be the line y equals x. Everything is getting flipped over that line right there. Okay? Everything's going to get flipped over that line right there. Okay? Now, kids, we're going to start running into things that say, what's the inverse of this function? Some functions will not have an inverse. And I'll show you why here in a bit. I need to check and see where they learned that, by the way. Okay. Did you guys get that y equals x written in there for line of reflection to refer back to? Yes, no, yes?
Yep.
Okay. All right, so let's run back to the second page here. Example 3 says finding the what, kids? Inverse of a quadratic. Okay. This is where things start happening. Okay, it says inverse for the graph of the function for x greater than what? 0. Okay, here's the deal. I'm going to put a graph up here. First of all, you tell me what function we're finding the inverse for. Is it x squared minus 2?
Yeah.
Okay. What shape do I get for that graph? A parabola. Okay, here's the deal. In order for a function to have an inverse, it must pass the vertical line, or I'm sorry, horizontal line test. You've heard of vertical line test before, right? Mm-hmm. Okay, so there's a new test called the horizontal line test. Okay, very simple. It's very simple. If I would start drawing horizontal lines through this graph right here, kids, then how many times is a horizontal possibly going to hit my function? Twice. Is hitting a function more than once good or bad? Bad. Okay, we're going to use what's known as a horizontal line test to test if it has a function. Now, if I drew a horizontal line test up there, if I drew some horizontal lines, would it pass or fail the horizontal line test up there? It would fail this thing. But here's the deal, kids. We would say there's no function that's an inverse to this because it fails the horizontal line test. But they put this little provision down here and they say, oh, and by the way, on this function, x must be greater than or equal to what?
0.
Okay, so what we're saying is this. We're only looking at the part of the graph that's from 0 to the what? Okay, if I start drawing horizontal lines, hang on a second, I need some tools. There we go. If I start drawing horizontal lines from 0 over, say from here to here, how many times will I hit the graph if I start at 0 and go horizontally? Once. So we're saying if you start right here, if I start right here, forget this garbage over here, then would it pass that horizontal line test? So do you understand why they say finding an inverse for x greater than or equal to 0? If I don't put that in there, it's including both the left and the right side, and you're saying, well, that's not invertible. Okay? So those provisions, you might see them like that. And it really just means you're still finding an inverse. So we're going to graph the function and its inverse. Let's roll with this, kids. You ready? Okay, to find an inverse, we have y equals x squared minus 2 first. Help me out, kids. What do I have to do first to find the inverse? So how am I going to set this up? All right, now how about next step? I'm sorry, Jasmine? Solve for y. So what's my first step in solving for y? Add 2, absolutely. So this becomes x plus 2 equals what, kids? So guys, if I move this up here, what do I have to do to both sides to get y to be alone now? Square root this. Okay. So y would equal the square root of what mess, kids? So if I'm going to put this in inverse form now, I would simply say, A, f inverse of x, which is really replacing that y right there. What's that equal? Well, the square root of x plus what? Okay. So let me go to my graph here, kids. First of all, are you okay on how I came up with the inverse there? Yes? No? Yes?
Yes.
Okay. throw some stuff in here. Let me do this quickly, kids. Anybody need more time writing that down?
No.
Okay, let me get into decimals. What was the original function again?
Yeah.
Okay. Let me change my window. I only want the x-axis to be from 0 and bigger, right? So there's that. I'll slide this over just a bit. Okay. What do we get for an inverse? Square root of. Okay, there's that. All right. And this is for all x greater than or equal to what?
0.
I'm going to put y equals x in here. Is that? Does that look like it cuts right in half again there, kids?
Yep.
Right in there. Okay, it's right in the middle of that stuff again, isn't it? Okay. What do you guys think? Are you good on finding inverses?
Yes.
What point is this right here about? 14 comma what?
4.
Means that the inverse of 14 comma 4 would be what? Let's see if we're right. 4 is right here. How about I follow this up to about here? Did you guys see it?
Yes.
Does it work?
So
Yeah.
do we need to like put that point down with all 3 inside?
Don't really need to. I mean, you could if you wanted to. That has nothing to do with anything yet. We're going to get to that eventually, but don't worry about it now. Okay? Again, what I'm trying to get you to understand is from 0 over, do you guys see how this is all kind of symmetrical right here? It gets cut in half here, and everything gets reflected over.
Yeah.
Makes sense? Okay. All right, let's move. Let's find another one. Finding the inverse of a cubic function. In fact, what I would like you to do is look at this. Consider the function 3x cubed minus 2. Determine whether the inverse of f is a function. Let's punch that in there, kids. 3x to the third minus what?
2.
Okay, here comes our function. 3x to the third. What's after that, kids? Okay, let me zoom home. Guys, you think that's going to pass the horizontal line test? If I draw a line here, how many times is it going to hit? Once. If I continue to draw horizontal lines, is it going to be invertible? First question. Yes, because it passes what? Is there any window we're looking at, or are we looking at the function as a whole?
Whole.
Okay, so the first question is this thing invertible? Yes. Invertible. Gosh, that maybe leads me to a new thing. Since it's not snowing in Iowa anymore, maybe I need a convertible for Christmas.
No.
Chevy Camaro convertible?
I
Yeah, I'm speaking your language now, right? Attaboy. Yes, invertible. Because
horizontal.
passes what?
Horizontal.
Okay. So let's find the inverse. So what do I have to switch around first?
X and Y.
X and Y. So I'm going to write this down first of all. Y is going to equal 3x to the third minus 2. So let's put our rules for finding inverses into play. What am I going to write next in order to find the inverse of this function? Or how to undo stuff? X equals. Okay, so what are we trying to isolate now? Trying to isolate Y. Here we go. What are you going to have first? Okay, I'll move my work up here. How are you going to get Y to the third alone now, kids? Divide by 3. So we're going to have X plus 2 over what? equals, and you guys have worked a lot on rational exponents and roots. What do I have to do both sides now to get y alone? You go cube root of both sides. So y will equal the cube root of the whole mess, x plus 2 over what? Now, I'm not going to make you get into rationalizing denominators or anything like that. Let's just leave it that way for now. Okay? I think you can get away with that. Check and see. What example was that? 4? 3? Yeah, we're good. Just leave it like that. Okay? All right. So, again, determine if it's invertible or not. Find the inverse. So I'm going to say f inverse here of x is equal to what? If I would graph both the original function and the inverse function, what should be the line of reflection for this? Y equals what? Should be a diagonal cutting right through that, cutting it in half, okay? How are you guys feeling about finding inverses? Switch x and y, solve for y. You're done. Okay? Switch x and y, solve for y. You're done. All right? Let's go to example 5. You know what? Determine if this is invertible. Okay, no problem. Where am I going to go to determine if it's invertible first? So in example 5, what is my function? I think I saw a 3 and then a root. What's under the root? What's the radicand? I don't know, guys. Is that going to pass the horizontal line test?
Yeah.
So is it invertible? Is there an inverse function that's going to exist? Yep, passes the what? Okay, so I'm going to say passes HLT, so we are what? So it is invertible. I'm not talking. You tell me what to do right here, kids. Switch x and y. So what should I write, Jazzy? All right. Gosh, I get caught in these stupid dots all the time. Okay. How many are buying what I'm selling so far? This is where things get kind of tricky. We got to isolate the what now?
What would you divide by 3? What? Divide by 3.
Yeah, we're going to divide by 3. Gnarly. Those cancel, right? So I'm going to move my work up to here. So where am I at? What do I have on the left side right now? X divide 3 is equal to what? All right, we've isolated that radical sign, so we've got to get that thing out of there now. Square both sides. So if I square the left, what's this going to become? Up top. X squared over will equal y plus 4 because we just did what to both sides? Okay. So how am I going to find my inverse function, kids? Minus 4. So do you guys agree the inverse will be x squared over 9 minus 4. So is it okay if I put it in function notation and say, all right, from this we have f inverse of x is going to equal x squared over what? Minus Woo. Okay. If I think there's anything that's really pressing or very important in here, I believe it's example 6. So I strongly encourage you, put a big star by example 6. Okay? And I'm going to make it a Christmas star today. So I'm going with green and red star. Is that okay? My Christmas star. You like my Christmas star? Verifying if functions are inverses of each other. Kids, inverses take y and x and really do what to them? They switch them around, okay? This is the part that's tough, okay? We need to show the following in this. I'm going to make a little t-chart like this. We need to show the following if stuff is an inverse of each other. We need to show that f of g of x is equal to x, and we also know to show that g of f of x is equal to x, okay? Now this notation, it looks like a nightmare. Would you agree with that? You're like, what are you talking about, Parson? Every day in here is a nightmare. So let's just continue the nightmare on Adams Street, 200 Adams Street, suite number 59. Here's what they're saying, kids. F of g of x is simply saying, okay, what function's on the inside here, kids? G of x. What they're saying is take this function g of x right here, which is what? They're saying verify that f of x equals 2x plus 4 and g of x equals x minus 4 over 2r, what of each other? Okay, we're going to do the first one right here, which says f of g of x, and I'm going to do this color in blue. So we're kind of saying, you know what we're saying? We're going to take this mess and we're going to plug it into the f function where the x is. So what they're saying is take your function g, plug it in for x in function what? And if I do this correctly and it is an inverse, then it should equal what? Okay, let's see this. This is going to become the following. F of g of x is going to become the following. It's going to become, all right, we're starting with which function, kids? F. And everywhere where there's an x in function f, we need to plug in the whole g of x function. Here's how this works. In f, what value starts it? 2. But right after the 2 is a what? But we're going to replace that x with the function g. So we're going to replace this x with everything over here. So what are we replacing the x with? We're going to replace it with x minus 4 over 2. No. No. And then minus or after that part, after I've substituted, what is going in there? Plus 4. Watch what happens here. Hey! What are the 2's going to do right here? 2 times this mess. These are going to cancel, aren't they? So we're left with x minus 4 plus what?
Plus 4.
So what are the 4's going to do? They're gone. Leaving us with what? Which means f of g of x is equal to what so far? Is that good or bad?
Good.
That's good. Now we have to do the exact opposite. We have to show that by taking, basically what you're doing is saying, okay, plug this function in where x is into the first function. Now we've got to go the other route. We've got to take and see what g of f of x is equal to. Basically, they're saying take your f function and plug it in anywhere where there's an x in what function? Basically, they're saying, well, take this function right here and plug it in for what? That's what they're saying right there. So let's see what happens here. This is going to become the following. Guys, in g of x, it starts out x minus 4. But what are you going to replace the x with now? 2x plus 4. So the top is going to become 2x plus 4 minus 4. Over what? What the 4 is going to do, wise guys and gals? Cancel. So up top you're left with over what? Which is equal to what? In both cases, f of g of x and the other, g of f of x, when I plug one function in for the other and vice versa, what do we get both times? And by definition, when both of those situations equal x, we say that those two functions are what? Okay. So your verification is to say that f of g of x in the end has to equal what here? Has to equal x. That's good. That's good. And what do we end up with down here? Is that good? Okay. That's your verification. Can I show it just one way or do I have to show it both ways?
Both.
Both ways. Okay. All right. Last example, number 7. Guys, I can finish it quick and then get you out of here, or we can do it first thing tomorrow morning. Let's stop there then, okay? So get organized. I'm going to send out the online for this.